In this tutorial, we're going to discuss inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So here's an example of an inscribed angle. Angle ABC is inscribed because its vertex B is on the circle, and then the two sides of the angle each contain a chord of the circle. So here we have this segment AB is a chord, and then segment BC is a chord of the circle. You can see that the inscribed angle intercepts this arc. So we're going to be looking at some theorems regarding inscribed angles. The first theorem is the measure of an inscribed angle theorem. This states that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So we have the measure of angle ADB. So I can see here that angle ADB is here. It's an inscribed angle because its vertex is on the circle and then the two sides are chords. It intercepts this arc, which we could say is arc AB. So what this is saying is the measure of this angle here should be 1/2 the measure of the arc AB. So the measure of this arc here, not the length, just the measure, so the degree measure. So before we talk about the two other theorems, I'm going to bounce to the first three questions here. I'm about halfway down the page. So it says, find the measure of the indicated arc or angle in circle O. So first, here we have circle O. I can see that I have inscribed angle BAC, whose measure is 37 degrees. So that's our inscribed angle BAC, and it's 37 degrees. This angle intercepts arc BC here. And what we've been told is that the measure of the arc is going to be double the measure of the angle. Or in other words, we could say the measure of the angle is 1/2 of the arc. So if 37 is 1/2 of the measure of the arc, that means we could take 37 and double it or multiply it by 2 to get the measure of arc BC, which is what we're looking for here. So 37 times 2 is 74 degrees. So the measure of arc BC is 74 degrees. Let's look over here at number 2. We're also looking here for the measure of arc BC. But in this case, arc BC isn't the intercepted arc. It's this arc over here. So let's see what our inscribed angle is. Our inscribed angle is angle BCA, and it has a measure of 48 degrees. That means that this should be 1/2 of the measure of this arc here, arc BA. So the measure of arc BA is double 48 degrees, which we know would be 96 degrees. Something that's important here is that both of these chords are going to be congruent to each other, which tells me then that this arc over here and this arc AC, those are going to be congruent measures as well. So what I can do is figure out what would be the measure of the entire arc BCA, that major arc there. So if I take 360 and I subtract 96 degrees, then that means I would have 264 degrees for this entire major arc BCA. So if I divide that by 2, that should give me the measure of arc BC, which is what we're looking for. So that would be 132 degrees. So this answer would be 132 degrees for the measure of arc BC. In number 3, we're looking for the measure of angle BAC. So angle BAC that we're looking for is this angle here. Now we're going to have to pull on some prior knowledge. I have here that angle BOC, which is a central angle, is 87 degrees. It's a central angle because its vertex is on the center of the circle. And as a reminder, a central angle's measure is the same as the measure of the intercepted arc here. So this means that the measure of arc BC right here is also 87 degrees. So if this arc is 87 degrees, then the measure of angle BAC should be 1/2 of that. So half of 87 is 43.5 degrees. So the measure of angle BAC is 43.5 degrees. Let's do one more. So here we have another inscribed angle. The vertex is on the circle and the two sides of the angle are chords. So if this angle measure is 5x plus 4 degrees, the intercepted arc is 208 degrees. So the arc that goes right along here and has endpoints that end on those two chord endpoints. So what we know is that the angle here, this angle measure, 5x plus 4, should equal half of the intercepted arc measure, which is 208 degrees. So half of 208 is 104. So 5x plus 4 should equal 104 degrees. So this angle here should be 104 degrees. We're looking for the value of x. So if I solve this equation by taking away 4 on both sides, 5x would equal 100. And dividing both sides by 5, we would get that x equals 20. So all of these equations and problems we were able to solve using this first theorem. The second theorem says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So if we look at our two inscribed angles, here's our first inscribed angle, angle ADB. And as you can see, this intercepts arc AB. Another angle, angle ACB, also intercepts arc AB. So since they both intercept the same arc, then both of these angles would be half of that arc's measure. So they're both half of that measure, which means they're both congruent to each other. So angle ADB is congruent to angle ACB. Let's use this to look at one of our problems. Here I can see that this angle right here, let me trace over it, this angle right here has a measure of 2x plus 11 degrees. And I can see that that angle intercepts this arc. Then I have another angle. This is an inscribed angle as well, and it intercepts the same arc. So these are two inscribed angles that intercept the same arc, which means they should be congruent to each other. So if I wanted to find the value of x, I would take 2x plus 11 and set it equal to 4x minus 3. So if I wanted to solve that, I could take away 2x on both sides. I would get 11 equals 2x minus 3. Then I could add 3 to both sides, so 14 would equal 2x. And then dividing both sides by 2, we would get x equals 7. Let's look at our third theorem. This theorem says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Think about why this is. If you have a right angle here, so this is your right triangle, if this is a right angle, then that means that you would have the inscribed angle ABC. It would intercept this arc here, which means the measure of this arc should be double the measure of the angle, so it would be 180 degrees, which means that it makes AC a diameter of the circle. So the hypotenuse of that right triangle is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter, then the triangle is a right triangle and the angle opposite the diameter is the right angle. So you can kind of go the opposite direction with it. So again, if the measure of angle ABC is 90 degrees, then that's true if and only if that segment AC is a diameter of the circle. So let's look at this problem here. I can see that segment BC is a diameter of the circle. It's a chord that goes through the center, which means that this arc right here is 180 degrees. This intercepted arc, it's intercepted by angle BAC. So this angle here, which would then have a measure half of 180 degrees, which means this is a 90-degree angle. We're looking for the measure of this angle here. So if this is 90 degrees and this is 50 degrees, if we take 180, since all angles, interior angles of a triangle add up to 180, and we take away 90 and we take away 50, we are left with 40 degrees. So that means the measure of angle X is 40 degrees. So let's apply these 3 theorems to 3 more problems. Find the measure of the indicated angle or arc in circle P. So in this, well, I guess this is circle P, but we also have circle E as well. So for any of these, we want the measure of angle A here. So that means this angle right here is what we're looking for. So I can see that this angle intercepts this arc BC. So I know that this angle is 1/2 the measure of this arc. Well, I can also see that AC, segment AC, is a diameter. So that means that this entire arc here, ABC, should be 180 degrees. So if I want the measure of just arc BC, I can take 180 and subtract 54 degrees. And that's going to get me what? 126 degrees. So that means the measure of arc BC is 126 degrees. So we know that the measure of this angle, it should be half of the measure of the intercepted arc. So the measure of angle A is 1/2 the measure of the intercepted arc, which is 126 degrees. So half of 126 is 63. Therefore, the measure of angle A is 63 degrees. In the second problem, I always like to highlight what it is that I'm looking for. So I want the measure of arc AB. That means that I'm looking for this arc here, that measure. Well, the first thing I notice is that I have an inscribed angle, angle BAC, which is 20 degrees. That means that the measure of the inscribed angle is half the measure of this intercepted arc. So if this angle is 20 degrees, then this arc here is double that, which is 40 degrees. Since AC is a diameter, then that means the entire arc ABC should have a measure of 180 degrees. So I can take 180 degrees and subtract 40 degrees to get 140 degrees, which is the measure of arc AB. So that would be 140 degrees. And the last one, the measure of arc VST. So VST is going to be this arc here. So if I want the measure of that arc, then that means that I need to utilize that this inscribed angle is 51 degrees. So if I double that, then the measure of this intercepted arc is going to be 102 degrees. So I can see here's 39 degrees for arc SV, 102 degrees for arc VU, and then 135 degrees for arc UT. So all the way around the circle would be 360 degrees. So if I take away 39 and 102 and 135, then I should at least get the measure of arc ST. So when I take those away, I get 84 degrees. So this is 84 degrees. So the measure of arc VST means I need to take 39 and add 84. And so total, we would get 123 degrees.